Today we are going to talk about Pythagorean identities. An equation that is true for all values of the variable is called an identity. Based on the Pythagorean theorem and is referred to as Pythagorean identity. This next equation I'm about to give you is something you are definitely going to need to know for the Regents exam. It does not give it to you. It is sine squared theta plus cos squared theta equals 1. Theta can be any value, and it says if you take sine of that value and square it, and add cos of that value and square it, you will always get 1. For example, it says verify that cos squared of pi over 3 plus sine squared of pi over 3 equals 1. All I want you to do is notice that we're plugging a pi over 3 in for theta, and it should equal 1. When you type this in your calculator, please make sure it is in radians, since it is a pi over 3 is a radian value. So you'll type cos, parenthesis, pi divided by 3, close parenthesis, squared, plus sine, parenthesis, pi divided by 3, close parenthesis, squared. If you type the cos squared pi over 3 in your calculator, you get 1/4. Sine pi over 3 squared gives you 3/4. 1/4 plus 3/4 equals 1. So you showed that the equation is true. A couple things I want to talk about before I do the next two. Just like we have that sine squared plus cos squared equals 1, I have two other things that are important to know for today's lesson. Off to the side, write this for me. Tan theta. You know tangent is equivalent to opposite over adjacent. You also know tangent is equivalent to 1 over cotangent. But tangent is also equivalent to sine theta over cos theta. That means cotangent theta, while it is 1 over tan theta, it is also equivalent to cos theta divided by sine theta. That's going to help us today. It says use the Pythagorean identity to justify that that equation is true. And this is an actual question that can come up on the Regents exam. And this is what you have to do. You have to first know what the Pythagorean identity is. And we already know it from above. Okay? So I'm going to start by just writing that. So I have sine squared theta plus cos squared theta equals 1. What it wants us to do is to start with this identity and get to 1 plus tan squared theta equals secant squared theta. Look what I just wrote over here. I said tangent was equivalent to sine divided by cosine. I see a sine in this problem. What I'm going to do is I'm going to divide it by a cosine. Now the reason I'm going to do cosine squared is because the sine is squared. But we know from equations that whatever you do to one piece, you have to do to the rest. So I'm going to divide the cos squared by cos squared, and I'm going to divide the 1 by cos squared. Now when I take sine divided by cos, I know sine divided by cos is equivalent to tangent. So sine squared divided by cos squared is equal to tangent squared. Cos squared divided by cos squared, well, anything divided by itself is 1. So plus 1 equals 1 divided by cos squared. 1 over cos squared is equivalent to secant squared. So what you did is you started with the Pythagorean identity, and you showed how to get to tan squared plus 1 equals secant squared, which is exactly what you wanted to do. So this is all you would have to do for this problem. And it would likely be worth 2 points on the Regents exam. The only other one they can ask is to use the Pythagorean identity to justify this other equation instead. Well, since we're using the Pythagorean identity, again, you're going to start out writing it, which is sine squared plus cos squared theta equals 1. This time I look and I need to get to a cotangent. Well, I know cotangent is equivalent to cos divided by sine. So in this problem, I do see a cosine. So what I'm going to do is I'm going to divide it by a sine. And again, I'm going to divide by sine squared theta because the cosine is squared. And just like last time, whatever I do to one piece, I have to do to it all. Now I look and I try to simplify. Sine squared divided by sine squared is equal to 1. Cos squared divided by sine squared is equal to cotangent squared. And 1 divided by sine squared is equal to cosecant squared theta. And now you use the Pythagorean identity to get to the cotangent squared theta plus 1 equals cosecant squared theta. So you're done with that type of problem. Let's move on to something else here. It tells me cos of theta is 1/3. It tells me I'm in the 4th quadrant, and I find the 5 remaining trig functions. What I'm going to do here is I'm going to make myself a triangle. A right triangle. I'm going to call this angle my theta. If I know cos of theta is 1/3, then, and I also know cos of theta is adjacent over hypotenuse, then I know the adjacent side of the theta needs to be a 1, and the hypotenuse needs to be a 3. I can find the third side of this triangle by using the Pythagorean theorem. The Pythagorean theorem will be 1 squared plus x squared has to equal 3 squared. So 1 plus x squared equals 9. X squared equals 8. Take the square root, x equals radical 8, which is 2 radical 2. And that's what goes for this third side. Now that I have the 3 sides of my triangle, I can find my 6 trig functions. Sine theta is opposite over hypotenuse, so it's going to be 2 radical 2 over 3. Cos theta is adjacent over hypotenuse, so 1/3. Tan theta is opposite over adjacent, so 2 radical 2 over 1. Cosecant theta, you flip the sign function, so it's going to be 3 over 2 radical 2. And we do know we need to rationalize by multiplying by radical 2. So we'll have 3 radical 2 over 4. Secant theta is going to be flip the cos fraction, 3 over 1. Cotangent theta is going to be 1 over 2 radical 2. Rationalized by multiplying by radical 2 will give you a radical 2 over 4. There's one more thing we have to remember to do when we do these problems. Notice it says theta is in the 4th quadrant. In the 4th quadrant, cosine and its reciprocal are positive. Everything else is negative. So I'm going to stick a negative on the sine, the cosecant, the tangent, and the cotangent. I'm going to leave this next problem for you guys. It's the same idea. Draw yourself a triangle, come up with your third side, and then come up with your 6 trig functions. Next piece, it says write the given expression in terms of sine and cosine, and then simplify. So, tangent. Tangent, if you look above, is equivalent to sine over cos. Cotangent is equal to cos theta over sine theta. So we expressed it in terms of sine and cosine. Now it says we need to put it in simplest form. Well, the way we put it in simplest form would be to try to add these fractions together. Remember, in order to add fractions together, you need a common denominator. The common denominator between cos and sine is cos times sine. So the second one needs a cos theta, and the first one needs a sine theta. Sine times sine is sine squared theta. Cos times cos is cos squared theta. Cos times sine is cosine for that denominator. Okay, now that I have it as one fraction, I look to see if there's anything else further I can do. Sine squared plus cos squared from the very top of this is equal to 1 over the denominator. That cannot change at all. And that's it for that problem. Finally, let's look at the last one. We're going to do it together, even though I am over the 10-minute mark, just because I feel like it's something we definitely need to practice together. Cosecant. Well, that is equivalent to 1 over sine squared theta. Minus cotangent is cos theta over sine theta, divided by tangent, which is sine theta over cos theta. The second piece here, I'm going to move over. I'm not going to look at that first piece yet. Moving that second piece over to make that a little bit easier, I'm going to do a state change flip. So keep the first, change division multiplication, and flip the second. Oops, cos theta over sine theta. So this is the same as cos squared theta over sine squared theta. So I have a 1 over sine squared theta minus cos squared theta over sine squared theta. Denominators are the same, so I can combine it. It's going to be 1 minus cos squared theta over sine squared theta. Now this is where you think you might be done. However, that numerator, and you will get used to seeing this, that numerator can simplify more. Remember this identity, the Pythagorean identity. Sine squared plus cos squared equals 1. Now, look, let's see what happens here if I just move the cos squared theta to the other side. And you'll see why I did that in a second. Look at the right-hand side. See how it matches the numerator? That means 1 minus cos squared theta is really just sine squared theta. So I'm going to call this just sine squared theta over sine squared theta, which is just 1. At this point, you guys can do the one problem I skipped, and we will work on more of this type of problems tomorrow.